This video will introduce you to the basic foundation of organic naming. Specifically, we're going to work on the organic alkanes, alkenes, and alkynes, and then also organic alcohols. So within the molecular naming structure, there's an entire system called organic naming. And organic naming is based solely on compounds that are carbon-based. Okay? They have what we call a carbon backbone, meaning the major component of the structure is carbon, and then there are other things potentially bonded to the carbon. In this class, we're only going to be responsible for understanding 4 of the main naming systems for the carbon backbone. Okay. But we aren't going to cover something called functional groups. So the different groups that are attached to the carbon chain add additional components to the name, and we're just going to learn the backbone. Okay. So essentially what we're naming is compounds that have carbon and hydrogen. Okay, so C, some number of carbons, H, some number of hydrogens. And there are 4 major systems in terms of how we can organize our carbon-hydrogen compounds. Okay, alkanes, alkenes, alkynes, and alcohols. And each of these different systems, there'll be a different ratio of carbons to hydrogens, essentially, because they have a different number of single, double, and triple bonds. The first component of understanding how they're named is that they're named based on how many carbons are in the compound. Okay? If there's 1 carbon in the compound, it's got a prefix of meth. 2 carbons is eth. 3 carbons is prop. 4 carbons is bute. 5 is pent. 6 is hex. 7 is hept. 8 is oct. 9 is non. And 10 is dec. So for all 4 of these naming systems, the beginning of the name will start with one of these 10 prefixes based on how many carbons are within the structure. Okay. So if that CX was C4, the name would start with bute. So that tells you how many carbons are there. The next thing we have to figure out is how many hydrogens are there. And that is unique to the 4 different types of organic compounds. So if we are talking about alkanes, alkanes always have a ratio of carbon to hydrogen, where if you take your number of carbons and multiply by 2, and then add 2, that's the number of hydrogens you will have within your compound. So the example pentane, pent is the prefix, ane tells you it's an alkane. Okay, so pentane, pent is 5, so I know that the structure will be C5. And then in terms of how many H's there are, well, for anes, okay, so pentanes, the number of H's is always 2 times your number of carbons plus 2 more. So 2 times 5 is 10, plus 2 more is 12. This will be pentane. And if you draw out alkanes, what they're going to look like, this is your carbon backbone with 5 carbons. If you count up the number of lines attached to carbon, basically I fulfilled carbon's need for 4 things bonded to it, and each of these lines represent where a hydrogen is. Okay, so we have 1, 2, 3, 4, 5, 6, 7, 8, 9, 10, 11, 12. This is pentane. Anes are always with single bonds. Okay, it's basically all of the carbons bonded together with single bonds and then hydrogens there around it to satisfy how many you need. Alkenes, on the other hand, in order to figure out number of hydrogens, you still take your number of carbons times 2, but that's it. You don't need those extra 2. And the reason that happens is because at one location within the carbon chain, you have a double bond. So let's talk about the alkene, pentene. Again, pent is your prefix, so all alkenes end like that. Okay. So pentene, still your 5 carbons. But now to figure out your number of H's, it's just carbon times 2. Okay. So it's just 10. And if you draw this structure, before we had 12 total hydrogens to satisfy all of these bonds, but now you only have 10. And the reason we only need 10 now is because there's 1 double bond, meaning there's 1 less hydrogen in this spot and 1 less hydrogen in this spot. So now you only have 1, 2, 3, 4, 5, 6, 7, 8, 9, 10 total hydrogens. Obviously, it's a resonating structure. That double bond could be anywhere along this chain, but alkenes, okay, things that end in -ene, you have one double bond. In order to figure out your formula for alkynes, alkynes is still your number of carbons times 2, but now you take away 2 more of those hydrogens. And the reason you take away 2 more is now you have another bond. It could be a triple bond or 2 doubles, depending on the structure, but essentially you have another duplicate bond where you don't have hydrogens. Pentyne. Pent, again, is your prefix, so the alkynes end with the Y-N-E. Okay. So pentyne is still C5. But now to figure out hydrogens, you take that times 2, which is 10, and then you take away 2 hydrogens, so you only have 8. If we look at our basic carbon backbone, the alkynes that we just had 1 double bond. This one will now have 2 double bonds to essentially take away 2 more hydrogens. So there's 1 here, but you don't need 1 here, so we removed that one. And this one used to have 2, and now it just needs 1. So 1, 2, 3, 4, 5, 6, 7, 8. The other variation could be that this is a triple bond, right? And then I would move that hydrogen up here. Still 8. It's just that you have 1 more bond for the alkynes. So now how do you name it if I give you the chemical formulas? Well, first you have to figure out what the prefix is. So C3 tells me that it's prop. And then to figure out whether it's ane, ene, or yne, you have to look at your number of carbons. So the first thing for all of these was look at your number of hydrogens. The first thing for all of these was carbon times 2. So carbon times 2 in this case will get us 6. And I have 2 more to get to 8. Anes were carbon times 2 plus 2. So this is propane. This one right here, to get, carbon times 2 gets me 12. To get to the 10, I'm taking away 2. When I took away 2, I was in the ynes. C6 is hex, so this is hexyne. So when it comes to trying to name them, you have to figure out what the ratio is of the carbon to hydrogen, whether it's +2, what it is, or -2. Your last carbon group are the alcohols. It's a little different because we're not just taking away an H in this case. Alcohols have the basic structure of alkanes, except they have 1 less hydrogen, and in the place of that hydrogen, they have an OH group, okay, that hydroxide group. So in order to figure out the alcohol formulas, you take your number of carbons times 2, and now you only add 1 to it instead of adding 2 to get the alkanes, and instead you add an OH group to replace that 1 hydrogen that you don't have. So pentanol, pent is 5, so you're going to have C5. And then the rule is carbon times 2, so that's to 10. You add 1 hydrogen to it, so that's 11 total. And then because it's an alcohol, you're going to add an OH group to the end. Okay. So what this structure actually looks like, this was our basic pentane structure. And when we counted the hydrogens again, 1, 2, 3, 4, 5, 6, 7, 8, 9, 10, 11, 12. There are 12 spots for hydrogen. Well, in one of these spots, it's an O bonded to an H instead. So that's why your hydrogen group went down by 1 and was essentially replaced by the OH that you added to the formula. So that's your basic structure for organics. Now you're ready for worksheet number 3. Have a nice night.